In this video, I'll be going over the setup of the Instron machine in order to do the lab for strengthened materials entitled Stress Concentrations using the Photostress system. Now, before watching this video, you want to make sure that you watch the Instron Basics video because I'm going to be doing some setup here that assumes you've been through this once. So at this point, if the Instron machine is set up with a very typical configuration, say you've just done tensile testing with wedge grips and the 50,000 Newton load cell on here, I'm going to quickly go through the steps of tearing this down and getting ready for setting it up for the samples using the photoelastic material. So first thing that I'm going to do is remove the wedge grips. Before I remove the load cell, I'm going to unplug it over on the side. Remember that you want to have the machine off at this point. I'm using the large Allen wrench on the end of the torque wrench in order to remove the load cell. There's a cable strain relief on the back side. You want to unclip that. And as I pull this off, I want to make sure I don't lose the alignment pin that is in between the load cell and the cross member. The alignment pin stayed in the load cell. I'll make sure not to lose that. For this lab exercise, we won't be dealing with large forces, so we're going to use the 2,000 Newton load cell. There are two of these, and so you want to set up both Instron machines. One Instron machine will be doing tension tests on the photoelastic material, and the other Instron will be doing bending on the photoelastic material. Again, there are two of these. There's a ring on the top side of the load cell. You want to make sure that's in, and I'm also going to put the alignment pin in. I'm going to orient the alignment pin towards the back. I take the bolt that was holding on the 50,000 Newton load cell. Recall that there are two washers that are used to hold this large bolt on. I'm going to take those off and use those. The smaller bolt that is used for the 2,000 Newton load cell already has one washer on it. I'm going to leave that one on and place the other two on as well. I'll tighten down the load cell bolt with the small Allen wrench. And I'll plug in the cable on the back side. I'm going to place the cable in the strain relief loop on the back of this column to hold it in place. I've got the cross member positioned such that the gap in between the load cell and the bottom mount is about the length of the two tensile specimens that we're going to be testing in this particular lab, the one with the hole and the one with the notches. So when you have about that length in there, it's time to mount the hardware that holds those pieces in place. Now, the hardware that's used for that is aluminum, and it was made here at UC Merced, and there are a couple pieces that go with it and a couple of pins as well. First of all, for the bottom mount, we have the piece that looks like this, and it is held in with the 1/2-inch pin that is typical for the DM mount. Now, I'm going to pull out the spring down in there. Go ahead and set that in for now, and then I'll put that in place in just a minute. But I'm going to point out that for the top, we have a different piece of hardware, and we use a small 6mm pin to go directly into the type OM mount at the top in the load cell. So pulling the clip off, I'm going to have the slot in the mount running this way, and that'll make sense in just a minute. And now for the bottom. Again, the slot running this way. I can now slide one of the tensile coupons down in. There are two pins that hold this in place. The pins will be with this hardware. Same bag. And it just slides in There's nothing to keep it in there, but it's okay, it'll stay put. There's nothing pulling it in or out. And of course I need to lower the cross member at this point to get it into place. Being careful. It's really important to put the hard limit stops in place for this experiment to do our best to protect these samples. So what I'm going to do is put the bottom stop right underneath the pointer. There's no reason to be going down any, we're only pulling, and so we want to make sure that the students don't push it down and bend this by compressing it. For the top, we want to lower it, obviously not all the way down because we need to pull on this sample, but I'm going to get it really close because the amount that we're pulling on it is very small, and that'll protect our specimen. So that's the setup for the tension test with the photoelastic material. I've taken the sample out because now I'm going to show you how to do the bending test with that same material. It's two same specimens, the one with the hole in the middle and the one with the notches on the sides. Now, I would suggest setting up both Instron machines, one with tension, one with the bending, but just for demonstration purposes, I'm going to go ahead and set up this same system with the hardware for bending tests. Before we can mount any hardware in the machine, I want to show you some changes that needed to be made to the 4-point bend hardware that we have. So this 4-point bend hardware is just that. If we were to take a sample and place this across here, it's being supported obviously by 2 points. And then we come down and push with 2 other points in the middle of the specimen to create this 4-point bend scenario. Now what this does is this obviously creates bend, but if you were to draw the shear and bending moment diagram, you would see that in between here you have bending only, there is no shear. And so we refer to that as pure bending in this area. That's the purpose of doing a 4-point bend test. You have no effects due to shear. So we need a way of holding this specimen nicely in the bottom fixture. And the way we do that is by taking and installing these guide blocks that have been made. These guide blocks require a 6mm hex wrench to install, so I'm going to show you how to do that. I'm going to remove the cap screws that hold these pieces into place here. And slide that out. I need that fastening hardware, so I'm going to remove that. We're going to take our guide blocks, and they're going to be positioned such that the slot is on the inside. Dropping the cap screw down in there. And then the nut slides in the track on the bottom. I'm going to leave it slightly loose so that it can slide back and forth. And I'm going to do the same on the other side. In order to set the distance, I'm going to take our sample, slide that in there. We want to make sure we have enough room so that it slides in and out easily. And then I'll tighten down those cap screws. They don't need to be super tight. There's nothing that's going to be forcing them in one direction or the other. And that's how that fits. With that ready to go, I'm going to install this in the machine. I've removed the hardware that is specific to the tensile test. Now I'll go ahead and put in the hardware for the 4-point bend. Starting with the bottom. And then the top. Note that we use the 6mm pin again at the top and a 1/2 inch diameter pin at the bottom. Once you have those pieces in place, you're ready to turn on the machine. If it isn't already, move this down until it just touches this surface right here. Now you'll note that there's a little bit of wobble in this piece right here. That's actually good, because when this comes down and touches this beam, we would like it to be able to adjust slightly such that the 2 points touch. Because if there's any gap, say just a few thousandths of an inch gap, as this one comes down and this one touches first, then you really have 3-point bending. And in a 3-point bend, the whole shear and moment diagram information looks different in this area, and you won't get what you want. So that completes the hardware setup for the 4-point bend attachment. Now I had mentioned that you can set up one machine for tension and another machine for bending. In that scenario, the idea is to have 2 groups running at one time. We have 2 Photostress systems, and so you could do that. But in that scenario, one group would be working on tension, the other on bending, and when they both get done, they would swap. That's one way to do it. The other way to do it is, since we have enough hardware to have 2 machines going in terms of the 4-point bend and tension attachments, you could also have 2 groups, one at each machine, and the group that, when a group finishes doing the tension, then they could swap out the hardware, if you've shown them how to do that, to put in the 4-point bend attachments. And then that way they can continue on at their own pace. So that's another way of doing it. This concludes the portion of the demo on how to attach the hardware to the Instron machine. Next thing I'm going to talk about are all the attachments on the Photostress equipment to get that up and running. I'm going to go through the setup of a Photostress system. It should be known that there are 2 complete systems. So we have several black cases around that contain all the parts necessary, all the components necessary for running these kinds of experiments. But again, there are 2 complete sets. Now before you see one complete set. There are 2 black cases, a tripod, and a laptop to make one complete system. And I've only got one of them sitting here. Of course, there would be an identical setup that would go along with this if you want to have 2 groups of students running this experiment at the same time. I'll also point out that there are many black cases around here. There's probably about 8 of these black plastic cases. Several of those cases have components in that we do not need for this particular experiment that we do. So when looking through all the cases, you want to find these 2. One of them has on your screen on the right hand side, you've got the Polariscope, the power supply, the lamp that it's used to illuminate the test specimen. And then on the left side, you've got the video camera and a couple of other interface devices. And in the other kits, you'll find things that are used for making the specimens themselves. So you'll find all kinds of chemicals and mixing cups and a heater plate, and those components you don't need for this exercise that we do. So I'm going to walk through the different components mainly so I can give them a name. That way when I begin to set things up, you'll know what I'm talking about and where they came from. I'm going to start with probably the heart of this system. It's the reflection polariscope, this component here. There's a countersink screw that's in the bottom of it that we'll use for mounting purposes. You've got the lamp that lights up your specimen. It's a white light, very, very bright, and makes it easy to see the color bands. This is referred to as the digital compensator. We've got a laser that helps you visualize the axis of strain that you're viewing. So it's just a tool to help you keep things straight in terms of what direction you're looking at. We've got a power supply for the lamp, some cables, extra bulbs for the lamp. We've got the tripod that holds everything, the reflection polariscope, the video camera, the digital compensator. Of course, the laptop that runs the PS Calc software. We've got a video camera that, instead of just viewing the color bands with the naked eye, we can connect this video camera. What that allows you to do is show the image on a computer screen so more people can see it. It also is necessary when trying to calculate stress and strain values. That camera comes in handy. We've got some interface cables here, power supply for the video camera, more interface cables. The camera requires a FireWire connection, and so this plugs into the laptop. I believe it's called the PCMCIA slot, and that's what this is used for. This box here is a Compensator USB interface box. So the digital compensator that I showed just a minute ago, this goes with it in terms of connecting via USB to the laptop. Those are the major components. I'm going to pull everything out and we'll start connecting it and getting it set up. At this angle, you can see the tripod's been set up. This is the top of the tripod. That's where we're going to mount the Polariscope and the video camera and the light or lamp. I've also included in this view the Instron machine back here. Your sample would be, of course, set in here, viewing that. So we're kind of looking from behind the system forward at the Instron machine where the sample will be. I'll go ahead and put on the reflection Polariscope first. Notice the orientation of the tripod is such there are two dowel pins that are up at the front. Those dowel pins interface with two holes at the bottom of the reflection Polariscope. And you want this set up such that on the right hand side, when you're looking from the back of the system, you want to see the angle numbers on that dial there. Now the screw on the bottom, of course, is very important. We don't want to drop the Polariscope, so I'm going to get that started before I walk away because I don't want that thing falling off of there. And then, of course, what we'd want to do is tighten that down. For demonstration purposes, I'm just going to get that finger tight. Next thing I'll do is I'll go ahead and attach the lamp. In order to attach a lamp, you'll notice that there are three dowel pins on this left side of the Polariscope. Those three dowel pins are going to interface with the holes in all of these tabs. So what I'm going to do is I'm going to hook the bottom or the top. It doesn't really matter. Maybe I'll go ahead and do the top first. I connect that on first, and then I'm going to pull the bottom tab down. It's kind of springy to attach the bottom pin. Now you can see that this still rotates, so I'm going to attach the other side. Let me give you a different view of that. We're over on the side of the Polariscope. Notice the top and bottom clips still have that rotation. I'm going to take this, loosen it up a little bit, put it on that side dowel pin, get the lamp so that it's straight, and then tighten it down. We're now over on the other side of the setup. I've got the video camera that I'm going to place on. I've put the battery into place. We also have an AC adapter, but I believe you have to have the battery in place as well. Took the lens cap off. In the black cases, you'll find a bag of nuts and bolts, and so you want this fastener to hold the video camera in place. There's a hole on the bottom to thread into. With the video camera fastener started, I'm going to slide it pretty close up to the Polariscope, within just a ½ inch or so, and gently tighten that down. It doesn't have to be super tight. Once again, we're at the back of the system. I'm going to show you how to attach a digital compensator. Before we do, I want to tell you to have this knob at the top. So that knob can be loosened and we can rotate this. But for now, we want it at the very top. There's a 0 and an arrow that you can line up. It's not that critical right now, but we want that at the top. That puts this tab over on the side like this. We're going to make sure that that's tight because we don't want this rotating right now. We've got the digital compensator, and so I'm going to attach that. You'll notice that there's a slot here for this tab. So I'm going to loosen, pardon me, in case I was out of the view there. We've got this slot and this tab. I'm going to slide that on there, tighten it up. There's a 9-volt battery in this digital compensator. You want to make sure you have extras on hand just in case that battery goes out. We're going to be turning this knob over on the side here. This one's pretty squeaky, but we'll need that as we run our experiment. While we're here talking about the digital compensator, I'm going to go ahead and connect the cable to the back side of that. This cable will interface with the USB interface box for the compensator, which then goes to the laptop computer. You want to find the cable that looks like a Cat5 Ethernet cable, and that plugs into the back of the compensator. While we're plugging in cables, might as well finish up plugging in all of the cables that come out of the setup near the Polariscope. We've got a FireWire that we can plug in for the signal or the video signal from the camera to the laptop. Go ahead and find that FireWire cable, plugs in over on the side in the AV out connection. I'm also going to plug in the power cable for the camera. You definitely will want to do that. For the lamp, we've got a cable that looks like this. Got several pins that plugs into the back side of the lamp. If you do want to use the laser, we can connect that right now. Of course, the laser looks like this. There's another tab over on the side. Back off that fastener, tighten it up, and then we plug in on the side for power. Now again, this laser is not absolutely necessary. All it does is it projects a line rather than a point, and the line corresponds to the zero angle or x-axis of your viewing. Continuing with all of our connections, I'm going to take the plug or cable that we plugged into the back of the lamp for power, and here's the power supply. Make that connection. And of course that just gets plugged in. Once you have that plugged in, your lamp will work, which also powers the laser if you've decided to use that. Of course, we can plug in the video camera. Let's move on to some of the other connections. This is the FireWire cable coming from the video camera. That's going to be plugging into this adapter card, which we're going to plug in to the laptop. Place the FireWire interface card. FireWire cable can go into either slot. Plug that in. Next, this is the other end of the cable coming from the compensator. That's going to plug into the compensator USB interface box. You'll notice that there's a green dot on this compensator box. That green dot is an identification to go along with the green dot on the laptop. The reason that this interface box has to match the laptop is because the serial number for this has to match the serial number in the PS Calc software. If you don't have the right interface box, the software won't work. I'm not sure why it's set up like that, but that in fact is the case. So you want to make sure you have those matched up. Now for the other system, there's not an indicating dot on it. There's not some other color. It's just not marked. And so the green goes with the green, and the other set has no indication on it. With that wire connected, I can take this adapter wire, plug that in here, and then this just gets connected via USB into the laptop. After making all the cable connections, you're going to find you have a mess of cables. And those cables are going to be situated on the ground. And what I would suggest is taking and using zip ties and organize some of this, because students need to stand in the area where the camera is pointed right now. And we don't want them tripping over those cables and pulling off equipment off the tripod. So you'll want to take and kind of gather those together, zip tie them together, maybe zip tie them to one leg of the tripod along here somewhere, and then get those tucked up underneath the table. You want a little bit of a gap between this table and the tripod so students can stand back here and use the equipment. I've got the video camera for the Polariscope removed because I want to show you a couple of things. Now this video is specifically for the setup of the Photostress system, not necessarily the use of, but I do want to point out a couple of gotchas just to make sure that the equipment isn't damaged. First of all, when you rotate the angle of the Polariscope by loosening this knob, you want to make sure that you're careful not to let it drop. Notice that the compensator moves with it, and so if you loosen it and just let it go, if this isn't tightened down well enough, we don't want to lose this compensator. So once we get it back into position, we want to make sure we tighten it well. For the experiments that are done in this lab, this knob right here, we always want to make sure that it is lined up with the M and not the D. You'll notice there's a small D and a small M on this scale, and so we always want to have it on the M for making measurements of stress and strain. One of the last things I'd like to show you is the fact that these cameras come with a demo mode turned on. Now I've turned that off on both of them, but it seems like when the battery gets critically low or it's been a long time something, that demo mode comes back on, and it's really frustrating because what it does is the image that you see, it'll cycle through these different effects that it can put on the image, like kind of a starry snow effect, and so that of course is not something that you want turned on. So what I would do is to make sure that that demo mode is off. In order to do that, there's a menu button on the camera, so we would hit the menu button, and this I know is going to be really hard to see right now, but there's also a scroll wheel right here, and if you scroll that down, it gives you different options, and all the way up at the top, if you go down almost to the bottom, you'll see a screen that includes demo mode. Now this scroll wheel right here is a scroll wheel and a push. So I'm going to push to select certain items, and you'll figure it out, but get your way down to demo mode and push again if it's on. You can scroll back and forth to do on and off. So we want to make sure that's off. I push the scroll wheel to do that, and then to get out of this mode, I'm going to hit menu. So that will save you a lot of frustration if you can remember to do that, if you're looking at the video camera image and you're seeing all kinds of different effects happening to it. I'll go ahead and install this back on the Polariscope so it's ready for use. This concludes the setup of the Photostress system. One thing that I should have mentioned at the beginning, I'll go ahead and wrap up now, is to mention that you want to have the Photostress system about 5 to 6 feet away from your test coupon, which would be sitting right here, which is made of the birefringent material. That way you get close enough such that the camera can see the image well, and you'll get a good distinction of the color patterns. Good luck.